Hi, we're on US Highway 50 at the top of Echo Summit, looking down into South Lake Tahoe. People from all over come to South Lake Tahoe to go camping, fishing, hiking, and in the wintertime skiing. But we're here today to do some carpool chemistry. Today, we're going to show you how to convert units using dimensional analysis. Let's say you're given a large number of grams, 2,875 grams to be exact, but that's kind of a big number. You want to convert that to a larger unit called kilograms. Here's how we do it using this technique called dimensional analysis. The main equation is what we want is equal to what we have times conversion factor or factors, depending on how many you have. Underneath want, you write down what you want. Well, it says you're given 287.5 grams and you want kilograms. So you want kilograms. Underneath have, you write down what you have that's going to help us define the number of kilograms. Well, it looks like we have 282,875 grams. And then we need a conversion factor that converts grams to kilograms. Well, if we look at our charts here, we see that for mass, 1 kilogram is equal to 1,000 grams. So write that down. And I usually choose the larger unit first. The kilogram is the big one. So one of those kilograms is equal to 1,000 of these smaller grams. From that equality, we could take two ratios. We could say there's either 1 kilogram for every 1,000 grams, or we could say there are 1,000 grams for every 1 kilogram. Well, these two ratios here, in these two ratios, the numerator or the top number is equal to the denominator or the bottom number. And if you have the same number on the top as you have on the bottom, overall, the value of your fraction is going to be equal to 1. And we could multiply this 2,875 grams by the number 1, and it will still retain its value of 2,875 grams, even though it might be converted to a different unit. Which one of these two ratios do we choose to multiply by? You choose the one that's going to make your grams cancel out, leaving us with kilograms, which is the first one in this case. So I'm going to multiply by 1 kilogram for every 1,000 grams. And notice how the grams cancel out, leaving you with a unit of kilograms. And then you could either do this this division problem in your head, or you could use your calculator, because not all problems are going to be divided by 1,000. And so you simply punch in 2,875 times 1, and then this big line says to divide by 1,000. And you have an answer of 2.875 kilograms. Now let's take a look at, well, what happens if instead of giving you grams and asking to find kilograms, what happens if they do the opposite and they give you kilograms and ask you to find grams? You use the same technique. Want is equal to have times factors. But in this case, you want grams, and you have 3.58 kilograms. And now you have to multiply it by a factor that relates to together. And like we said before, 1 kilogram is equal to 1,000 grams. And if that's the case, you could say that there's either 1 kilogram for every 1,000 grams, or you could say there's 1,000 grams for every 1 kilograms. Now in this particular case, we would multiply our 3.58 by the second one in order to make the kilograms cancel out. Unlike in the previous problem, we multiplied by the first factor to make our grams cancel out. So let's go ahead and multiply it by 1,000 grams for every 1 kilogram. Notice how the kilogram cancels out, and you're left with 3,580. 3.580 grams. Okay, and we can confirm that on our calculator. 3.58 times 1,000 is equal to 3.580 grams. Okay, one more problem that I'd like to do for you guys is notice how here we had a direct connection between kilograms and grams. And you know, one thing I want to point out over here is that on this first one, it looks like to convert from grams to kilograms, you divide by 1,000. To convert from kilograms to grams, you multiply by 1,000. Please do not memorize that, but rather work it out, and the multiplication or the division by 1,000 will take care of itself when your units cancel out. Finally, what happens if you had a unit of length, such as 980,000 centimeters, and you want to find out how many kilometers it is? Well, you simply write down the same thing. Want is equal to have times factors underneath want. What do we want? Kilometers. What do we have? 980,000 centimeters. Well, do we have a factor that relates centimeters to kilometers? If you look at our chart over here, we see that 1 meter is equal to 100 centimeters, and 1 meter is equal to 1,000 millimeters, a kilometer is 1,000 meters, but nowhere here do I see a direction between centimeters and kilometers. So, as in the previous problem, sometimes we have a direct flight, like from San Francisco to New York. Sometimes we have a direct flight from grams to kilograms, but sometimes we have to stop at an intermediate location along the way. For example, from flying from San Francisco to New York, you sometimes have to stop at a common city, which is Denver or Chicago along the way, which is halfway in between. In this case, we need to find a common unit between centimeters and kilometers. And what unit is common between centimeters and kilometers? It looks like the centimeter is related to the meter, and the kilometer is related to the meter. So we're first going to convert from centimeters to meter. And meters is the bigger unit, so 1 meter is equal to 100 centimeters, as we see from our chart right here. And if we do that, we say that there's 1 meter for every 100 centimeters, or there's 100 centimeters for every 1 meter. And in order to convert from centimeters to meters, we want to use the first one in order to make our centimeters cancel out. Times 1 meter for every 100 centimeters. The centimeters cancel out, but we still have the unit of meter left. We really want kilometers. How are meters and kilometers related? From our chart, 1 kilometer is equal to 1,000 meters. So we write that down. 1 kilometer is equal to 1,000 meters. And from that relationship, we could write down that there is 1 kilometer for every 1,000 meters, or we could say there's 1,000 meters for every 1 kilometer. And which of these two ratios will cause our meters to cancel out? We choose the one with meters in the denominator, so we multiply this expression by 1 kilometer for every 1,000 meters. And once again, we can do this legally because the number on the top is equal to the number on the bottom. Therefore, the value of this fraction is 1. We're multiplying this by 1 and 1, and it still retains that same value of 980,000 centimeters, or that's the same quantity. And I think now that we cancel out the meters, we have kilometers left over, which is a unit that we want. So we can go ahead and put down our equal sign, and let's do that calculation. 980,000 times 1 divided by 100 times 1 divided by 1,000. Hit our equal sign, and I come up with 9.8 kilometers. From US Highway 50 at the top of Echo Summit, this is Carpool Chemistry. Thanks for watching.